Good afternoon, everybody. Good to be here. Like Mac mentioned, I have been blessed to be able to present at all of the third or fourth year that we're doing this, and just, like Mac mentioned, I've been at General Motors for 22 years, and I've been working in the downtown Detroit area for most of those years, and to think now, to see where we are now, and to think that we're actually down and attending developer conferences and culturally themed developer conferences at that, it is exciting, right? It's a time when I started at GM that those kinds of things just weren't available. They weren't here. It's kind of opportunities to be able to collaborate with peers like this just wasn't there. So credit to the whole team putting this on. Credit to Mac and Jessica and everyone else who's been putting this on and leading it. And I'm just happy to be able to be here. Okay, so again, my name is Andrew Cameron. My role at GM is called a technical fellow. It means I've been there a long time and I've been doing one thing for a while, and that one thing has been identity and access management. I enjoy it, I have a passion for it, and I've been involved in pretty much, I'm a technical lead for identity at the enterprise level, so I'm pretty much involved in anything that's related to identity and access management. So that means everything that deals with the 200,000 or 300,000 users that we have as employees, the additional million users that we might have that are contractors and suppliers and extended users with the company. I deal with the architecture, design, and working with the teams and making sure that the security design of everything that we build meets a certain quality. And in the most recent years, I've also been involved with the customer-facing element of what we do at GM. So obviously you're familiar with us in selling cars, and if you own a GM car, you might have a subscription to OnStar, and you might be using our mobile app. And so everything that's going on involved with that in terms of how that mobile app is secured, I've had some element of influence in that direction as well. So it's been really rewarding, fun time to be able to be involved in those things at an enterprise level. And in most recent years, I've evolved from, and identity itself as a discipline has evolved from kind of users and passwords to this whole broader enterprise security focus, right? And so what I'm going to get into today is going to be more about what is zero trust, right? If you probably heard it, you guys are in tech, you probably heard it, and you probably think of it more as a buzzword. And I'm here to tell you it's really more than that. It is a way of thinking and a way of applying security principles that will be how we end up securing all of our IT systems in the future, no matter where you are. So that'll be interesting, and I'll get into obviously some of the deeper levels around API security and some best practices that are recommended for you guys who might be on the developer level and are implementing systems where you're not necessarily in a large enterprise, but there still will be practices that you're going to want to follow and understand. And hopefully we'll have some time for questions afterwards as well. So, okay, so there's a disclaimer. Then here's, if you've ever seen a talk that I've done before, I'm sort of in the bag for Marvel. So that's why you will always see at least one reference to something Marvel in my presentations, because that's just how I grew up and that's how it is. So I'm here to say that Spider-Man No Way Home, great movie. But the thing that always stuck with me, and this has been something that was in the comic books when I was reading them as a child, is that this whole kind of IT and learning how to use IT is something that's empowering, right? And it's with great power, you're supposed to understand how to wield that power and to be responsible with it. And so that's kind of what security allows you to be able to do. It allows you to be able to bring good things to your users, but also you're also focused on keeping their information and what's valuable to them secure. So that's my tie-in to Marvel. So that may be a little corny, but forgive me if that is. The other thing, part of the disclaimer I want to cover is that I don't, I have a job, but I don't represent anybody, and my opinions and everything that I give are my own. So if you agree or disagree, you can yell at me after the session. Don't blame anybody that I work for. How about that? Okay. So I mentioned zero trust, and again, you've probably heard, there's a lot of commercial buzz out there about what zero trust is, and I'm here to tell you that if someone markets to you or your company that buy this and you'll be zero trust compliant, buy this and you'll be leveraging a zero trust architecture, it's probably a salesperson who is trying to sell you something and doesn't really know or understand exactly what it means. Zero trust is not a product. It is a way of approaching IT, and I'll get into some of those details on why that is going forward. I'll get into API security, obviously. I'll get into things like what a token-based architecture is. I'll get into best practices, what the OWASP organization is, OWASP API Top 10, why that's important, why you should know what that is. I'm an architect at heart, so everything that I do is I'm always going to have a geeky architect picture there as well. And then I'm also going to walk through kind of a setup, a configuration of an application in the cloud environment. I'm most familiar with Azure and Azure AD, so I'll walk you through how that works in terms of how you configure your API services to be properly secured. And so I'll go through that in a bit of a walkthrough and a demo, and we'll have time for questions after that. Okay, so zero trust. I won't drain the slide. Most definitions that you'll see about zero trust really cover three areas, and it really focuses on always continuously verify the identity of the person that's trying to access whatever you're trying to secure, right? So there's that verify explicitly piece of it, right? The other part of zero trust in terms of the definition of what it means, and that when you're securing things and you're designing services in a secure way, you assume breach. You assume that anyone accessing your service could be maliciously intended, right? And so there's a reason for that. There's a reason for having that mindset. And what I've seen is that's one of the more difficult things that it's for people to understand is that, there's this whole concept that you might be, if you're on an enterprise network, if you're on an internal network, that you can be trusted. And really that is not the case anymore, right? I mean, all you got to do is take a list of the last 5 enterprise security breaches that you've seen out in the press, and you'll probably see examples of some kind of internal malfeasance that caused it, some time of leak of a credential, and so you can no longer assume that the boundaries of your enterprise network are secure. And so that's really one of the core principles with zero trust about. And then, least privilege is another aspect that has been a security principle for a long time, and that really just says everyone should only get access to only what they need to perform or do their job or to execute their role. And so there's a lot of statistics out there around, if you look at all of the access privileges that people get within an enterprise, what they use versus what they're actually given in terms of access, they probably use about 5%, maybe even less than 5% of the access they're actually given. So that what that means is there's a lot of excess privilege that's out there, and if you have an account that's compromised, that attack surface is much broader than what you might realize. So that's why that's an important concept to understand. So let's get into the more technical details of zero trust and how access control is implemented around it. Everything really revolves around kind of what we call a signal. And so a signal is something that really is, it could be a log entry and a sign-in log. It could be a push notification sent to another service. It could be an API call that's sent to another service. And really what you want to understand from a signal is you want to be able to assess some kind of risk. You want to be able to understand that is the person signing in to my resource, can they be, what level of trust can I assign them, right? What, in that risk, you can then assign based on, are they on a device that you trust? Are they coming from a network that you trust? Are they coming from what we might know as a bot network or a maliciously formed set of accounts that were exposed in a security breach? So all of that information ends up giving you the ability to kind of assess the risk of the user that's authenticating to you, and with that risk, then you can take some action, right? And then I'll get into more about what those actions are. And one more thing about risk, there is two different types of it. There's a device level risk, and so what that means is that if you're coming in on a device that either is not managed, or if you're coming in on a device that is, or your browser, you could be coming in from a dark net, on Tor browser, things like that, you can set policy to block those kinds of activities, right? And so those are the kind of risk, whether it's user-based risk or device risk. With that risk information, you now then can make a decision to what to allow the user to do. And so that decision is usually about allow, deny, or you could actually then force some kind of additional verification, force that step up. And that's really the part of zero trust that is the most important thing to understand, is the identity verification, the authentication piece of it. That's really where a lot of the innovation is today. Let me get a show of hands. How many of you know what a passkey is? Oh, that's good, good. So passkeys is what we call, it's a implementation of a transferable credential. So if you're familiar with FIDO and hardware keys and YubiKeys, those are hardware credentials, and now passkeys are more of a software-based credential that's linked to the identity ecosystem that you might be associated with. But the big benefit of passkeys is that they're not phishable, they're tied to a device, and they really represent our best opportunity to be able to move into this passwordless existence, right? And so that's where all of the major vendors, Apple, Google, Microsoft, have supported it, and they're now rolling out that capability. Apple and Google have rolled it out, and you'll start to see, and there are actually a lot of sites out there now that support it. And so what that means is you're going to be able to start to not use passwords to get into anything anymore, right? You're going to be able to use your phone, do fingerprint verification, and you won't even need to manage a password credential that can be compromised and reused and stolen and things like that. Okay, so that's the enforcement part of it. I kind of covered that already. The enforcement really gets into understanding the risk of the user that's signing in and applying a policy. So you may have, very, top secret, confidential resources that you're protecting in your enterprise, and you want to be able to say that, anyone that accesses this application, because it's our critical design system, they have to do a two-factor regardless, right? That's just something a policy that you might set. So that enforcement piece of it is part of an overall policy that you can set based on, how critical the resource that you're protecting. So again, this is another kind of busy picture that gets into kind of how zero trust is implemented in an enterprise. And so I talked about user and device risk. The other thing that is become really important in being able to protect resources within an enterprise is kind of this threat intelligence. And so, there are services out there that, have I been owned? Have you guys seen that service where they basically harvest all of the data breaches that are out there, and they give you a web service that you can use to tell me if my account has been exposed in a in a breach? Well, now there are companies that are actually, providing that as a service, and you can actually integrate that into the login flows of your applications, right? And so now that's that threat intelligence. So if you get some kind of match, you can apply that risk, and then you can use that to say, hey, you know what? This credential, this email address has been breached, has been discovered in a breach data set. We're going to require you to reset your password and to set up a two-factor credential before we let you access anything, right? And so that's kind of the way where threat intelligence plays a role there. And so that's kind of everything on the left. And one of the recommendations that I'm going to get into is kind of the concept of where identity is this control plane to really guide that access to everything. And you want to make sure that you limit the number of control planes, because that's where it gets more complicated to manage it. If you have 1, 2, 3, n number of identity providers that your enterprise deals with, it gets really complex to manage at that point. So you really want to focus down to it. If you can get to one, that's great. And that way, the policies that you apply at one point can then be spread across all of the resources that you're protecting, right? And that kind of really simplifies as much as possible what you're trying to do. And everything on the right deals with, the type of resources that get protected, right? So whether it's, documents in some kind of a cloud storage, all of the apps that you're developing. And then it even also applies to legacy systems, right? When I say legacy systems, I'm referring to primarily things that are running in your data center on-prem. And, pulling all of this together, the last piece of it that's part of a zero trust overall model is a really kind of deep introspective analytics and modeling, monitoring capability. And that's really important because you have to be able to have a continuous awareness of what's going on with your key systems. And there has to be, and that's where the machine learning and the deep analytics of all of the logs that are being generated from your systems, that's where it's important to be able to have security tools that can kind of have a continuous monitoring of your logs and give you an idea of abnormal activity, and give you an idea of, this guy in HR all of a sudden is accessing engineering documents and he's downloading 2,000 engineering documents. Do we think that's a problem, right? And so you can actually set policies to kind of monitor that kind of activity and throw flags and to be able to block that whenever it's necessary. So that's where kind of that monitoring and analytics capability is really an important part of zero trust. Okay, let's get into some API security, and I've covered some of these topics in terms of why APIs are generally vulnerable. And this is the part where we can get into debates around what is recommended and what is in practice today. And I'm sure you guys are developers and you've come across APIs that might use a key, a static key to access and secure an API. You might see APIs that do basic authentication where you put credentials in the header. I'm here to tell you that those are things that you're going to probably want to be moving away from. And the modern way of securing APIs moving forward is using tokens, is using JOT tokens. And that's, it's pretty much been kind of embraced by the standards. So if you hear me refer to a standard, it's the identity standards that really matter here are OpenID Connect and OAuth. And if you combine those, and then I could go another hour talking about just how important those standards are in terms of how you secure the enterprise, but you want to make sure that you're leveraging those standards in everything that you implement or develop. And so that is kind of the primary, and okay, I didn't shut down Teams, and so I'm getting all these messages in Teams. Let me close this. There you go, okay. Okay, so token-based architecture is the way that you're going to want to go, and I'll get into some more detail in terms of why that's really important. If you look, and again, if you monitor kind of the reasons why a lot of these enterprise breaches happen, you'll see that there's all types of keys and critical access information that are actually in public GitHub repos, that people can do scanning of GitHub repos and get access keys. And that really makes your CISO kind of scratch his head, like, why are we doing that, right? And so that's another reason why it's important that you really shouldn't use that as a secure mechanism to try to protect your APIs. SolarWinds is an example of a really huge breach that the start of that breach. Now there were a lot of things they did once they were actually able to extract the key out of a repo and pollute their software supply chain. But the start of it was that they discovered, there was a key that was discovered in the public repo, and it allowed them to then access the actual software that they were selling to their customers, and they were actually able to put Trojans into the software and allowed them to compromise a number of their customers. So very important, and that's why, again, moving away from those static key methods of authentication are really important. Broken logic and API definitions, I'll get into the OAuth's top 10 again, but you'll see a lot of examples of, I talked about the fact that there's tens of millions of compromised accounts out there, and so what the hackers will do is they'll do password spray attacks where they'll get a number of accounts that might link to a particular service, and they'll just automate the login attack against a particular service. In whatever they find that will actually successfully authenticate, they'll just use that to bounce around and gain access to more resources with it. So being able to, again, table stakes, but MFA is something that if it's externally exposed to the internet, MFA is absolutely required for everything that you have your users doing. I think we're a lot better now than we were a few years ago, but it's absolutely something that's highly recommended. Again, there's the other issue that in API endpoints that has been a problem is that if you don't implement token-based authentication correctly, if you're doing sort of like an implicit OAuth flow, there are actually scenarios where the browser history can store tokens that can be used to access applications, and you have to be really careful about that when you implement authentication in your applications. And so it's also possible that hackers can do, they can sniff API and do profiling of your API connections and get all types of critical information out of it, get personal information out of it. So that's also something that you want to be careful as you move that forward and be able to, again, moving towards more of a modern auth approach is something that's going to make a big difference for you. So again, best practices. Know your attack surface. Know what you have to protect, right? There's a lot of folks who have been out and developing things, and what they do is they move on to the next, they move on to what's important, and they don't even know that they have services that are exposed to the internet and require governance, to require upkeep and additional protection. So always be aware of what your total attack surface is. I mentioned using a token-based architecture, very important, and that really should be the only way that you authenticate access to your services. And so every request to every resource should be based on token-based architecture. I talked about OpenID Connect and OAuth. And again, as a newly titled security guy, it just goes to show you how important identity has become in terms of overall security, right? And so being able to understand those standards and how to implement them is really important. I'll talk about in the next slide in terms of how important an API gateway is. The role of the API gateway has kind of evolved. I would say maybe 5 years ago it started off as kind of this everything. You can use it as an identity provider, or you can use it as everything to kind of protect your APIs. And I think now it's evolved into something that's more about protection, and it's more, we kind of leverage the enterprise identity provider to integrate with the API gateway is kind of the better way to go about it, and I'll cover that in a moment. Scopes and claims. There's a lot of, I would say, opinions around whether an API scope should be used to authorize access to resources in the back end, having a clear understanding of what scopes are and their relationship to protecting your APIs, and why claims are more of what should be used for doing authorization. So just authentication is kind of identifying who you are. Authorization is what do you have access to. And I'll give you an example of what a token looks like and how extra attributes look in a token that can be used for authorization. But understanding scopes and understanding how to use that to protect your APIs is also very important. And I can't even give justice to how important it is to have a continuous security scanning capability. And so there's a lot of cool tools out there. I know that there was a gentleman that did a talk about Postman earlier. And there's a tool that I just discovered recently called, I think it's Pint. It's a security scanning tool that you can run in Postman that does a lot of basic core security scans of your API. And so I highly recommend putting one of those kind of personal level security tools into your repertoire, because that'll, as a developer, that'll give you, a more rigorous discipline around scanning and making sure that you can get security issues identified earlier, as early as possible. Okay, so again, here's the geeky part of it is, I'm an architect, so I love architect pictures, and so everything always starts, again, with the client. And I put the word untrusted there is because in the enterprise scenario, there's tools that allow you to do kind of device management. So if you either get a phone or if you get a laptop issued to you by your company, it's highly likely that there's some kind of software on there that does a fair amount of monitoring and making sure that not only are you not accessing the wrong things, but that it will be able to provide some kind of protection if you click on a malicious email or if you access some kind of website that could try to inject malware into your device. And so primarily, if you're dealing with customer-facing services, public-facing services, you want to make sure that you are aware that every client, everyone that accesses your application is generally untrusted. So you're going to be accessing resources on the back end, whether that's something that's running in Kubernetes or APIs or your applications. And so this, again, is the identity piece of the puzzle that is really important. So that not only does it provide the function of actually authentication, but then there's this token management component that's really important. So if you're familiar with OpenID Connect and OAuth, you get an ID token, an access token, and a refresh token. And those are really the only things that you should need to be able to access any APIs that you develop on the back end, right? And so, there's a deeper discussion around how you use an access token and a refresh token, but in general, access tokens are pretty short-lived, 1 hour lifetime. And if you try to access something, if you post your access token to an identity provider and it's expired, then you can actually post a refresh token and you can get it renewed. And that's kind of the cycle that you go through when you're accessing things on the back end. The important thing about that is the access token is what's called opaque, right? And so even though it does contain information that could be of value, the client app, the user on the front end, is not necessarily aware of it. And when you present that token through your API gateway, it is able to then translate that into a broader set of information. It can exchange that token and use it to access resources on the back end. But the key thing is you're not in a dialogue with an untrusted client passing personal information or whatever else to an untrusted client. So that's called the phantom token approach. And that's really, it's an important thing to understand because there's a lot of one of the OWASP's top 10 vulnerabilities is kind of this excessive information exposure, right? Where you post too much information, you load up tokens with too much personal information, and you make sure I'm on time here. Okay. And so you want to be aware of the information that you're exchanging over the wire to your clients. Another key component of the architecture overall is a web application firewall. And so what that means is that's your real first line of defense when you expose information, expose services on the internet. So when you put api.company.com out there on the internet to get called, you want to have, even before someone tries to authenticate to your service, you want to be able to have this bot protection. You want to have cross-site scripting protection. You want to have all of these, very basic, still relevant though, protections that you can block before they even get into your enterprise infrastructure. So very important to have that as part of the overall solution. And then like I talked about, there's the API gateway component that then handles less of a security role and more of an infrastructure analysis role where it's implementing things like rate limiting, it's doing validation of your tokens, and it's interacting with your identity provider to make sure that anything that gets past the API gateway is something that has been validated, right? So that's kind of really important. The last piece of it, again, that I can't even really give justice to is a CASB. So CASB is short for a Cloud Access Security Broker. And that really is a component that allows you to put deeper protections into your applications. And so, a lot of you folks are probably running Microsoft Cloud solutions, Teams, OneDrive, SharePoint. And so a CASB solution will allow you to set policy on a SharePoint site. It'll allow you to set policy on a OneDrive folder, right? And it will give you the ability to do things like I talked about earlier, that if you have something that's top secret or sensitive, you can set policies that will require somebody to step up and do an MFA challenge if they were trying to access it. So CASB is also a critical part of the overall modern auth scenario. Last thing I wanted to cover here, and again, I talked about how the WAF provides pre-auth protection, how the identity solution and the app gateway gives you that auth protection, and then the CASB gives you that overall data protection. Okay, what I want to do now is I'm going to pivot over to an Azure environment and show you a setup of a typical app registration and how that app registration is configured to support an API scope and integrate with the backend API. And so hopefully I can do this and not experience too much demo embarrassment. Let's see, put the glasses because of life. Okay, so this is my API management environment, and I also want to pivot over to, so Azure, we're an Azure shop. Most of my cloud skills are Azure-based. This is actually a sample app that's built in Azure B2C. There's also the enterprise version of Azure. It's called Azure AD. B2C is obviously a directory service, cloud identity service that's targeted towards larger scale customer-facing solutions. They support the millions of users on the back end. So my example I want to show you is that, again, when it comes to app registrations, there's going to be two apps here. So there's one called Web Front End, and that's the app that's going to be presenting a login screen. And with Web Front End, there is a configuration there that should have. There are configured with the app registration are the API permissions. And I talked about being able to develop APIs and expose access to your APIs through scopes. And that's what is displayed here. And I'll show you that if I wanted to add a permission, and then this is because I've registered this app already. I didn't want to take a full bust down and setup of the solution. So there's an area here called My APIs, and this is where it's aware of APIs that I've created and registered already. So I just registered one called Web Backend API, and with that, there is a scope called, it's a function app called LOFN. And so what should happen is that when the front end app authenticates, it should also get a scope in its token that will say hellofn.read. Now, when I tested this, it may not have been there, but that is what should happen here, right? So hellofn is the scope name, and that should be available in the token when I authenticate. And so now, the other aspect of this that you want to understand is OAuth is very much a delegated framework where it also can empower the user to say yes or no. So if you're familiar with, Facebook or LinkedIn, when you sign into something and using your Facebook or Twitter account, you'll get a screen that says, are you okay with using your identity from another service to log in here? So that's called consent, and that's also something that when you implement OAuth, you can require users to do that. In an enterprise scenario, you really wouldn't do that. So what I did here is I just did from an admin perspective, I granted consent, and so now the users won't see that when they get requested to access the service. So let's take a look at the web backend, and this is the backend API. And so here, where I expose an API, I created a scope, and this is the scope that is registered, and so I gave it a name, and I gave it some descriptive information. It doesn't really mean a whole lot, but what this does now is I can allow this API to be accessed by any apps in my enterprise, by any apps that I deem to be trustworthy, right? And so and I could have more scopes declared here, which would allow different backend APIs to be secured based on which application was accessing it and if they had the proper rights. So those are the two, and so the other thing about Azure B2C is kind of cool is that it gives you this ability to kind of no code a login flow. And so what I'm going to try to do, and the fact that I have a career that, identity-based demos, security demos are generally not exciting. And so you're not going to necessarily be too wowed by this flow, but at least I want to show you the token that gets generated here. So this is what's called a user flow. And what it will do is, there's some very basic user templates that Microsoft enables with the service, but what it allows you to do is that you can mock, configure, all of the aspects of the identity flow that you want, so that you can make sure before even a developer has to engage with it, you can see a login flow. If I wanted to configure a policy that required MFA, I could set that up here, and that's something that is abstracted. It's separate from the users that are accessing my application, and so that's kind of a cool part of the identity piece of it is once I could have this developed and ready to go, and once I register a particular backend application, they would just get a token that is properly configured that they can test with. So it's kind of a cool benefit. The other thing that I want to indicate here is, and this is what should, what this means is that the web backend API is the custom app that I created, and this shows, I'm assuming you guys can see my screen. Okay, good. And this shows the scopes that are going to be included into the token. And so what should happen is when I run this, I get a very bland looking sign-in screen, and I'm going to try to sign in. Super secure password with no MFA. And now this should return a token. Okay, here we go. And okay, so how many of us are familiar with the format of a JOT token? Okay, a few hands. So JOT token is made up of 3 components: header, body, and signature. And what's important about the signature is that it should not and cannot be tampered with, right? And so if the signature, for some reason, when you do your validation of the token, when the token is sent down to your application and when you validate it, if for some reason that signature validation fails, that tells you that there's something wrong and that you should not allow the user to continue, right? And so there's a number of other pieces of information here that, again, these are claims, and this is information that is statically set when the user is authenticated. And so you can use this information in terms of policy, in terms of how you secure the application going forward. So, for example, the issuer is something that you can trust as being issued by the identity provider. The audience, this AUD claim is the audience. That is the app ID of the application that's authenticating. And so you can use that in policy. You can use that in policy in terms of securing access to your resources. And in the event that an app ID is trying to access an API that it shouldn't, you can have policy that does that check and protect you accordingly. So that is the scope of my thrilling demo. I'm going to allow some questions. The other thing I wanted to cover, there is a GitHub repo. It's an API security GitHub repo that is really impressive, and I want to include that in the deck and invite you guys to go and take a look at it. It has cured a number of resources over quite a few years, but it is still kept up to date. and it is like all things API security. I will include that in the deck. And also I will include a cheat sheet on the OWASP API top 10. There was a lot that I wanted to cover with that I didn't, and I don't want to, that's a whole nother discussion I could get into. Let me see if I can bring up the cheat sheet before I wrap. Desktop, where are you, desktop? Okay, so this is a nice document. It gives a really good explanation of the OWASP top 10. So things that I talked about, broken object level authorization, excessive data exposure I mentioned, gives a good walkthrough of use cases and steps you can take to prevent it. So it's a good reference. And so now what you're going to see is that the security tools that are out there are going to be there that will be basically executing tests against these top 10 risks, right? And they'll be completely automated, and they'll spit out reports that'll tell you where those detections were found and give you the remediation steps that you should take to fix them, pretty much right in your code, right while you're in kind of that design time mode. So really, really nice advancements around the security tools that are going to be available. So that is it. Any questions?